In this video we will demonstrate a variation of single-slit diffraction, by making the aperture elongated in the direction of light propagation. In commonly demonstrated single-slit experiments, the aperture that blocks the light is made from thin opaque objects, such as paper, razor blades, and aluminum foil. Now the aperture is made much thicker using a pair of Peltier plates. They are chosen for having flat surface and rigid body, so consistent interference patterns can be produced. Don't get distracted by the wires, they will be set aside from the light path and don't affect the result whatsoever. Here's how the experimental setup looks like. The positioning of the equipment is important here. A piece of paper right after the aperture can be used to check their correct alignment, which will show only one bright spot. The central spot is bright enough to saturate the camera sensor. Turning the lighting on can reduce it. The overall brightness doesn't seem to change much due to automatic adjustment in the software. At longer distance, the pattern starts to spread wider. On the wall, the single-slit interference pattern is shown, where central bright spot is twice as wide as the side spots. The next setup is the elongated version of single-wire diffraction experiment. Previously, it was shown that single-wire diffraction produces the same diffraction interference pattern as single-slit diffraction, in accordance with Bobinet's principle. A name card will be used here to replace the single wire. Here's the setup. Without the camera lighting, the sensor is saturated, which makes the shape of the bright spot hard to see. With the lighting turned on, it can be shown that the name card casts a shadow behind it. On the wall, the central bright spot is just as wide as the side spots, which is more closely like a double-slit interference pattern. Let's turn off the camera lighting to compare with the result from saturated sensor. Let's compare the resulting patterns between the thick single-slit and the deep single-wire aperture. The depth or thickness of the aperture is rarely mentioned in textbook's explanation for single-slit experiment or wire diffraction experiment. Our results show that the diffraction entrance pattern of single-slit isn't affected so much by its depth. But for wire diffraction experiment, the thickness significantly changes the pattern. Let's compare the point sources of both diffraction interference patterns. They are the corners of the apertures. In single-slit type, much of the light from near corners are blocked by the aperture, thus can't reach the wall. While in single-wire type, the light from near corners are only partially blocked by the aperture, thus the unblocked portion of the light can still reach the wall. Once again, it's shown that diffraction interference pattern is produced by superposition of the light coming from the edges of the aperture, instead of the space around them.